Hello, this is David Birch at StarPath School of Navigation. Again, I just finished a video on this routing, some weather routing using this fine program Expedition in this region, and ended up with the statement that the GFS forecast was totally wrong in this region here. At the time this vessel here met this storm, the GFS was wrong. However, I left during that whole conversation, I left that map showing the weather map that wasn't applicable at all, and I didn't attempt to make a point which I could have done, and which I want to do now. Namely, I'm sitting in front of one of the most powerful programs possible to show such a thing, and so I should just show it to you, as I will, because it's important to remember that GFS unvetted numerical prediction model output can be wrong, and we must keep that in mind and check these things frequently. So let me go back and let's use as a comparison this time right here, okay, that is, oh, it's interesting, that's only 35 knots. This is an unusual, this is the National Hurricane Center report of this storm here of 35 knots. That happens to be an anomaly in a sense, because this storm really carried with it 40 knots almost all the time. Here they said 40, here they said 40, other places it was higher, but here for one day it said 35, but in fact this was all in the 40s. But so let's look at this place just on the corner here when the storm came up to here from North Carolina, and let's start looking at one that was so this is now July 14th, 15 Zulu. So I'm going to go back and load this 713. Okay, that's good. 713 Zulu map. So that's a map that was made. Let's go back to the very beginning of that map. Okay, so this map was initialized from and published by the National Weather Service Computer Division to be valid at 12 Zulu on Monday the 13th, and then they include the forecasts every 3 hours. So now we can just step forward and watch the things move here. The clock is probably ticking over here somewhere. I'm going step in 3 steps. Now here comes the system that was so wrong. This is actually a tropical storm of 40 knots of wind. It's not this little wimpy guy here. And it's actually coming up this line, not this line. But where are we here? 9 Zulu. Let's go up to 15 Zulu. Okay, there's 15 Zulu. So this is the map, the Global Forecast System prediction of this map of this area valid at 15 Zulu on Tuesday the 14th. Oh, Bastille Day, actually, it turns out. Now look at that. That's only a 27-hour forecast, a one-day forecast. Normally, the GFS is very good in 1-hour forecasts. So we're dealing here with an anomaly because this storm was created very quickly down south and then moved rapidly to the northeast. So, and they did not know that, or did not publish their knowledge of that, until 1700 on the 13th. So this map that came out 1200 on the 13th, they didn't know about it. So look how bad that is, though. Here we have a storm that's really centered here, and it's about 40 knots. And what you get is this low, you know, it's a low of what kind of pressure? I don't know, I'd have to see. This is like a 1008, it says here. Actually, the pressure of this low was not real low. It was like 1005, but and still, you know this. You see how here's another famous thing about these storms, this kind of storm anyway. that the storm moving this way, the winds are much stronger on this side than on this side because the relative motion adds to the winds here. But to the point at hand. Now we go back to, and I didn't show this on the previous film, but now let's load the wind that's valid, okay, at 7:14. See, this 7:13 at 12. They didn't know this till 7:13:17, but now they know it. 7:14:12. So now they know it. So we're loading this map, and then let's go back to the beginning. Oh, 7:12. Okay. 7:14:00. So look, already they've got this thing on the right track, and they got it looking like more like a tropical storm here. Remember, these isobars are showing, we can set this anything we want, but here they're set every 1 millibar. The convention on a regular map is 4 millibars. But anyway, this is still not 7:14:15. So we have to go up on this map, 12 Zulu. Oh, just one. Okay. So now here is 1500 on July 14th. That's a GFS prediction, 1500. And look at that. So there's where the real storm was located. And now with their new knowledge, all of a sudden the next day they've got this thing in the right place. It's absolutely in the right place. However, they don't have the winds right yet. Not at all. These winds here, look at this. These are, let me turn on this tool tip here. These are GFS winds. Where is the wind speed here? Oh yeah, 28, 30, 31, 30, 30. See, these are in the 30s. Whereas the actual wind was almost closer to 45. 40, 45 in this system here. So so there's another point. So that we have to, and we would have known that if you had just this GFS picture here. You wouldn't have known that. You'd think of 30 knots or something like that. Even though they now have it in the right place. Yesterday it was totally wrong place, over here somewhere. But they have it in the right place, but they don't have the winds right yet. So we have to always look at the real maps made by the National Weather Service. To get this real data here, not just rely on these computer models. I think I have a picture here. I'll just finish this up with a picture. Okay, here is a picture from another article that relates to this GFS problem in this particular storm. This is what time? July 14th, 00. Okay, so this is a little bit earlier, but it's the same basic idea. And this is the winds predicted at the peak of the storm here, and with this nice tool from Ocean's Grid Explorer for the PC version, and I can lay this along here, and it'll just give me a plot of the winds along that line, which is shown here. And what I've done in a video elsewhere is I swept this all around here. So just leave that fixed, sweep this all around, and you can see these are the strongest winds. I found the area with the strongest winds here, and sure enough, they're peaking around. This is what is that? 31. That's 35. So like 33 knots, 33, 31 knots, like that. Now let's go to the actual government forecast of that same thing. This is a pure GFS model output, computer model. When you download the GRIB files, that's what you get right here. But if you have a computer program that can actually download what's called the NDFD, National Digital Forecast Database. That is a digitized version of the real forecasts. So that's really the best kind of a GRIB file to put into your computer for your weather analysis if that data is available to you in that region, which it is in. What happens here, strangely enough, this is location here. This hurricane here, tropical storm rather, just moved right up here. Right up like this and like that, and this data ends right here. That's the end of the world as far as, oh, here you see it. The NDFD data does not go beyond here. It will, I think, eventually, but right now it doesn't. But here's the point. look at this area. It's 44, 45 knots right through here. So the two locations match pretty well, but the speeds are completely different. So that's what I wanted to show. I left that one the end of the last video a little bit hanging. This is a little more specific demonstration that the GFS model was not correct in this tropical storm. Thank you.